We'll be talking about minimizing with Galapagos this time, and the very maybe classical example for that is to finding out a minimum bounding box of a geometry. So let's create that geometry first. Create a box. Let's create sort of like another box. Let's create, I don't know, like a cone that is going over there. Rotate that cone, not that direction, this direction maybe, and sliding that in as well. Going to this direction too. Just take this, like take these geometries out by subtracting from this to these two, and I'm not sure, maybe another like a cylinder. Like let's create with start diameter and here as well, and rotate that and rotate that, and just select the wrong voice and putting this into one of our corners. Okay, and again, like I'm just sculpting sort of a geometry here. It's completely up to you. And then if I turn on these solid points, control points, putting this in, and maybe taking these points like that, deleting these points maybe, or increasing the volume of it. It's not that healthy, so maybe don't do that. Okay, so this is our B rep now, right? So what we can do here is pulling out a B rep, set one B rep, and imagine if you put a bounding box on top of this, right? Like this is the bounding box that we see. But what if the bounding box that can go smaller if we rotate this geometry a bit further? Maybe for that we can have a bit more angles here and there, a bit further angles. You see, nothing is changing right now due to the size of the bounding box because we are just playing around with the points, right? And that is like, we don't need to do the latest move, but that we can, something we can play around with, right? Pushing in, pulling out in these kind of things. But if we rotate these points, or if we rotate these edges, or if we rotate the geometry itself by rotating it on its volume, and on, like, let's say it may be a bit hard to find its volumes open shape, like let's say on xy plane, and ranging between 0 to 180. Okay, so when we do this and when we connect this, what we see is when we rotate this, our bounding box's volume is changing. And if we take this guy and do the same thing, copy this and paste it, but this time we are going to use our rotated geometry, and this time it's not going to xy plane, xz plane, because our box can rotate in 3 other axes too, right? And then this is the first one, this is the second one, and if I copy and paste this, it's going to be the third one, and the third one is going to be rotating on YZ plane, right? Put it in. So whenever we change this, you see that now our bounding box has changed, and obviously we can preview this off, and of course we can preview view off too, Rhino geometry, and we can take this preview on and put this as a wireframe so that we know exactly what to do with this. So this is the wireframe of it, and whenever we change this value, it is going to change. But I think I'll be changing my geometry here because now it seems it's having a bit troubles. It's a bit slow right now. So let me do something else here. Let me create a box, and let's take out like 2 other boxes. Let's create I don't know, like in okay, we can move this guy here. We can draw, I don't know, like a pyramid. Move that in, slide that in, extrude it a bit further. So we can say solid Boolean difference, take this out and take this and this out. You see a bit like a defined geometry, and maybe what we can do is we can take out an ellipse in between this geometry. So I can take this ellipse in, push it out. See, this is only for the speed concerns. Oops, that's too much. And if we know Boolean difference, see we have only one single thing here, and if we put this guy in instead of the previous one, now we can have maybe a faster kind of, yeah, you see it's way faster. So that's fine for now. And what I'll be doing is I'll be creating a Galapagos component here, and we'll be saying the volume, and the volume of this is going to be my fitness value, and my genomes are going to be rotations. And also, while I'm connecting genomes, I should be pressing shift as well, otherwise it will be connected only one single slider. And then this time minimize solvers, view all these solutions, and when I run this, you see it started to give me some solutions. Obviously my like sculpted geometry is not still very cheap in terms of computation time, but you see we are receiving results and we are getting a lot of like values here. Since I am working with millimeters, that is the problem. But then like you see that we are having the genomes here, it's getting over top of each other, and we are seeing this graph. By the way, this graph means we are creating the solutions, and what we are looking for in this graph is like this line, this orange and this yellow charts. When they get closest to one another, we actually find our desired solution, or closest to our desired solution. And what you see this time, it starts with 7 something something and goes to 2 something something. So it's still looking for that, like looking for that triangle that are actually constantly changing. You see, it may find something, or it's still trying to optimize the values. And what we see here, basically one other small note here, when these points are coming closer together, it means we are closer to a solution. Okay, so like again, like it's gonna take a bit of time, I think. And let's pause, or let's stop things here. You get the whole point. When you have enough time, you'll find the, but you see, the results are getting quite smaller according to what we have at the beginning. So you see, but sometimes it finds something larger. As I showed you at the beginning, it was like 8, but now it goes back to the 7s again, and so on and so forth. So let's pause for a second here, stop solver, and let's reinstate this value. When we reinstate this value, it takes the sliders to those values, and when we take it back, it gets those results. And when we select this, it gets this result. So this might be a one that we find quite closer to what we are looking for. And with this being said, we can wrap things around on this video. I can copy this and paste and add this to group, and like this can be the smallest volume. And yeah, so if I zoom into this portion a bit, and that is pretty much it for this video. That's pretty much it for this video. I hope you enjoyed it, and I'll see you in the next one.